Okay, good evening, class. Today we're going to continue on what we talked about today with functions, but tonight we're going to look at operations on functions. So the first one we're going to look up is adding and subtracting functions. So I'm giving you two functions. F of x is equal to negative 3x squared plus 2x plus 3, and then g of x is x squared plus 4x minus 3. So the first we're going to look at is adding and subtraction. So I have f plus g of x, which is basically just equal to f of x plus g of x. Okay, so you're just going to add these two together. So if I take f of x, I have minus 3x squared plus 2x plus 3, and then I'm going to add g of x to it, which would be plus x squared plus 4x minus 3. So we're going to want to combine our like terms. So our like terms here would be negative 3x squared and positive x. That gives me minus 2x squared. And then I have plus 2x plus 4x, which could be plus 6x. These two here are like terms. And then like terms here are 3 and negative 3. 3 minus 3 is 0. So my answer here would be minus 2x plus 6x. Okay, our second example, we're going to look at g plus f of x. Again, using the same examples, same two problems I got. So g plus f is going to actually equal g of x plus f of x. Okay, so we're going to just add these together. So g of x was x squared plus 4x minus 3 plus f of x, which would be minus 3x squared plus 2x plus 3. Okay, so here I kind of want to wonder if does order matter. Does it matter if I add g plus f of x or f plus g in the first example? So if I look at this example here, we combine our like terms. I have x squared minus 3x, which gives me minus 2x squared, 4x and 2x. They are like terms. 4 plus 2 is 6x, and then negative 3 plus 3 is 0. So my answer here would be negative 2x plus 6x. So I noticed that these are the same. So I know that addition is what we consider commutative property, and order doesn't matter. So I'm just going to write that down out here to the side. Okay, so real quick, I just wrote out here to the side that addition is cumulative and order doesn't matter. Alright, so our next example we're going to look at is f minus g of x. So again, I know from my original that f of x was minus 3x squared plus 2x plus 3. G of x was equal to x squared plus 4x minus 3. So I'm going to look at that again. So keep in mind, f minus g of x, this right here, is equal to f at x minus g of x. Okay, so I'm just going to do the math here. So I'm going to bring down my f of x and minus 3x squared plus 2x plus 3. And this time I'm going to put this one in parentheses. I know I didn't do that with the addition because addition we don't really need to worry about the minus signs, but in subtraction we do, because when I go to minus the second one, I have x squared plus 4x minus 3. Remember, we're subtracting this whole second quantity, so this negative gets distributed to everything in this. So this becomes a minus x squared, a minus 4x, and then a plus 3, because you're basically timesing it by a negative 1. And then the first one stays the same. Okay, so now then we can just go ahead and combine our like terms. I have negative 3x minus x, so that gives me a negative 4x squared. I have 2x minus 4x, so that gives me minus 2x. And I have a 3 plus 3, which gives me plus 6. So that would be my answer to this problem there, f minus g of x. So let's look at another one. If we did g minus f of x, again using the same examples as we did earlier, which would be f. So remember, this is going to equal g of x minus f of x. So I'm just going to take g of x, which would be x squared plus 4x minus 3. Put that in parentheses, minus f of x. Negative 3x squared plus 2x plus 3. Remember, we distribute this negative to everything in the parentheses. So this becomes a negative times a negative is a positive 3x squared. Negative positive is minus 2x. Negative positive minus 3. Bring down my g of x. And then we're going to combine my like terms. So I have x squared plus 3x is 4x squared. 4x minus 2x is plus 2x. Negative 3 minus 3 is minus 6. So this is my answer. So if I notice, these are not the same. So subtraction is not commutative and order does matter. So I'm just going to write that down. Okay, so I wrote that down here. Subtraction is not commutative. Order does matter with subtraction. Alright, so this time we're going to look at multiplying and dividing. So let's look at what happens if f times g of x. So again, this is going to equal f of x times g of x. Okay, so I have f of x is 9x and g of x is 3x cubed minus 18. Alright, so when we're multiplying polynomials, you know you need to distribute or FOIL. So let's just write that down. Use distribute or FOIL, depending on what your functions are. So I'm going to take 9x and multiply it by 3x and get 27x to the 4th, and then 9x times negative 18, and I get minus 162 to the x. Okay. Alright, so let's look at what happens if I do g times f of x. So same thing, this is going to equal g of x times f of x. Okay, using the same functions from the first one, I have g of x is 3x cubed minus 18 times 9x. Okay, I'm going to do the same thing. I'm going to distribute this way. We're going to have 3x times 9x is 27x cubed. I'm sorry, x to the 4th. And then negative 18 minus 9 is 162x again. So if you notice, from here order doesn't matter. So that must tell me that multiplication is commutative and order doesn't matter. Okay, so I'm going to write that down in my notes here. So write this down in my notes. Multiplication is commutative and order doesn't matter. Alright, so go ahead and pause that if you need to write that down, and then come back and see me on the division. Alright, so division with operations and functions could be tricky, but for the most part we are only going to look at dividing by a monomial. So in this case we have g of f, g divided by f of x. So this would be equal to g of x divided by f of x. Okay, so if I wrote that out, I'd have 3x cubed minus 18. F of x is 9x. So when we're dividing by a monomial, remember we can basically just break this down and have 3x cubed divided by 9x, and then minus 18 over 9x. And then we'll just want to simplify this. So remember, when in doubt, you can just factor everything out and write it out. So remember, when in doubt, write it out. So 1 times 3, and I have 3 x's. 9 will factor to 3 times 3 with 1x. Okay. 18 factors down to 2 times 9, which would be 2 times 3 times 3, because that's how you factor that out. And then 9 factors out to 3 times 3, and then you have an x. So now you just want to cancel everything out. This x cancels, this cancels, my 3 cancels, so I'm left with 1 over 3 and an x squared on top. And then here my 3's cancel, and I'm left with the 2 on top over the x. Okay, so this would be my answer to g divided by f of x. Okay, so this would be my answer here. Again, most of the time when we look at division, we're only going to be looking at monomials. Okay, and make sure you take the notes. Take good notes. Go back over, work a couple out. Make sure you understand and complete the form at the end of that follows the video. Thanks, and see you tomorrow.